Welcome all of you. Today we discuss topic chemical thermodynamics, topic number 4 from standard 12. This is the topic number 4 from section 1st. So we can start. First we discuss thermodynamics is concerned with energy change in physical and chemical transformations, and it gives information on rate of physical or chemical process or underlying mechanism involved in these. Terms used in thermodynamics: first, system, a part of universe underlying thermodynamic investigation is called system. All other part of the universe outside the system, such as cylinder, room and other, these are surrounding. The universe is made up of system and surrounding. Next, kinds of system, and we discussed types of system. There are 3 different types of system. So first, open system, which exchange both energy and matter with surrounding. You can see in the diagram the matter can exchange only with the surrounding. So this is known as open system. Closed system, that exchange energy and not matter with surrounding. It is a closed system which can exchange only energy, not matter. Third, isolated system, it does not allow exchange of either energy or matter with surrounding. That is, no any matter or energy which can exchange with the surrounding is known as a isolated system. These are the 3 different diagrams of this system. Next, we discuss properties of system. There are 2 different properties which are important. First, extensive property, and then next, intensive property. So extensive property, a property which depend on amount of matter in system is called extensive property. So these are examples: mass, volume, internal energy. These are examples. Next, state functions. So see in the diagram. Firstly, again we discuss properties of system. Extensive property, a property which depend on amount of matter present in system is called extensive property. Example: mass, volume, internal energy, heat capacity and number of moles. Next, internal, that is intensive property, a property which independent on amount of matter present in system is called intensive property. Example: pressure, temperature, surface tension, viscosity, melting point, boiling point and specific heat. So these are intensive properties. So question can be asked on extensive properties and intensive property. Next, state functions. See the diagram. These are 4 different state functions. So first, state functions, the property which depend on state of system and independent on path followed attained it is called as state function, which is independent on the path. म्हणजे अशी सिस्टीम की ज्याच्यामध्ये पाथ सिस्टीमचा इंडिपेंडंट आहे त्याला स्टेट फंक्शन्स म्हणायचे. मग त्याच्यामध्ये टर्म प्रोसेस of physical and chemical changes in system undergoing from one state to another also called as state functions. So this can be achieved by number of paths. म्हणजे हे स्टेट फंक्शन्स मिळवण्यासाठी कुठलाही पाथ आपण वापरू शकतो, कुठलाही मार्ग वापरू शकतो. तर त्यासाठी आपल्याला पाथ फंक्शन्स, दॅट इज द प्रॉपर्टी विच डिपेंड ऑन पाथ आर कॉल्ड पाथ फंक्शन. सो विच आर वर्क W and heat Q. So these are 2 important path functions. Next, process and types of process. These are important. So process means a transition from one equilibrium state to another is called process. So first process, isothermal process. in which temperature of system remains constant, that is delta T is equal to 0 throughout the transformation. So delta U is equal to 0. It is known as isothermal process. Second, isobaric process. The pressure remains constant during the transformation, that is delta P is equal to 0. It is known as isobaric process. Third, isochoric process. The volume of system remains constant during transformation, that is delta V is equal to 0. Isochoric process. Fourth, adiabatic process. In this process, no exchange of heat between system and surrounding, known as adiabatic process. So heat is equal to 0, that is Q is equal to 0. Fifth, reversible process. In this, neither expansion nor compression of gas occurs, that known as system is said to be mechanical equilibrium with surrounding. So these are known as a driving force P is infinitesimally greater than opposing force due to external pressure P external, and it can be reversed by slight change of opposing force to the known as a reversible process. ह्यालाच रिव्हर्सिबल प्रोसेस म्हणायचे, ज्याच्यामध्ये एक्सपान्शन आणि कॉम्प्रेशन हे आपल्याला सायमल्टेनियस होत असेल मेकॅनिकल इक्विलिब्रियम अटेन करण्यासाठी सराउंडिंग बरोबर. नेक्स्ट, features of reversible process. There are 4 different features. First, driving and opposing forces. These are differ by infinitesimal amount. म्हणजे ड्रायव्हिंग फोर्स आणि अपोजिंग फोर्स हे डिफर असतात वेगवेगळ्या इन्फिनिटेसिमल अमाऊंटनी. द प्रोसेस. दुसरा, द प्रोसेस कॅन बी रिव्हर्स्ड ऑन इन्फिनिटेसिमल चेंजेस ऑफ कंडिशन. जशा कंडिशनमध्ये तशी प्रोसेस ही रिव्हर्स्ड होऊ शकते इन्फिनिटेसिमल चेंजेसमध्ये. थर्ड, reversible process proceed infinitesimally slowly and takes place in infinite number of step. म्हणजे infinite number of step मध्ये ही reversible process आपल्याला प्रोसीड करता येते, ती स्लोली होते. फोर्थ, at the end every step of process the system attains mechanical equilibrium with surrounding. म्हणजे ती सिस्टीम मेकॅनिकल इक्विलिब्रियम सिस्टीम आपल्या सराउंडिंग बरोबर अटेन करते. तर हे 4 फीचर्स आहेत फॉर रिव्हर्सिबल प्रोसेस. नेक्स्ट, हीट, नेचर ऑफ हीट अँड वर्क. ह्यासाठी आपल्याला एक एक्सप्रेशन बघूयात. इन मेकॅनिझम द वर्क इज डिफाइंड ॲज एनर्जी बाय विच बॉडी इज डिस्प्लेस्ड थ्रू अ डिस्टन्स डी विथ ॲप्लिकेशन ऑफ फोर्स एफ. सो डब्ल्यू इज इक्वल टू म्हणजे वर्क इज इक्वल टू एफ इंटू डी. सो टाइप्स ऑफ वर्क इन्व्हॉल्ड इन पी व्ही म्हणजे प्रेशर व्हॉल्यूम डन ऑन द सिस्टीम वेन गॅस एक्सपांड or contract against external opposing force. So pressure P is defined as force per unit area. If D is the distance and A it is the area and V it is the volume is equal to D cube and area is equal to D square, then the equation for PV is equal to F upon A into V. So putting the value of A and V, we get F is F upon D square into D3. So D can cancel. So F into D is equal to W. First equation we also get, that is work is equal to force into distance traveled by the application of the area. So these are 2 examples discussed in here, decomposition of H2O2 and reaction of ammonia gas and HCl gas. So here example, twice H2O2 that gives twice H2O liquid plus O2 oxygen gas. Second, ammonia gas plus HCl that gives NH4Cl, ammonium chloride is prepared in this reaction. So this is the nature of heat and work. Next we discuss nature of heat, that is Q. So heat is form of energy by which system exchange energy with surrounding. Then the system and its surrounding are different temperature, either flows on let out of the system. म्हणजे एकतर फ्लोच्या आत असतील किंवा त्या सराउंडिंग सिस्टीमच्या फ्लोच्या बाहेर असतील वेगवेगळ्या टेम्परेचरवर. सो देअर आर 4 डिफरंट साइन कन्व्हेन्शन्स ऑफ डब्ल्यू अँड क्यू. म्हणजे वर्कच्या आणि क्यूचे 4 डिफरंट साइन कन्व्हेन्शन्स आहे. सो दिस इज इम्पॉर्टंट फॉर साइन कन्व्हेन्शन व्हेन प्रॉब्लेम सॉल्विंग इन फॉर एक्झामिनेशन. सो डेल heat plus Q, heat is absorbed by the system from the surrounding, minus Q, heat is released by the system to the surrounding, plus W, that work is positive when work done on the system by the surrounding, and minus W, work is done on the system on the surrounding. So these are 4 different sign. Note work and heat, that is W and Q, are the path functions. So next we discuss expression for pressure volume work. So expression for pressure volume work, PV work, is, you can see in the diagram. Consider a certain amount of gas at constant pressure P is enclosed in a cylinder fitted with frictionless rigid movable piston of area A. You can see here in diagram area A, which is having fitted with, this is a piston which is fitted in the hollow cylinder. So this is known as in the below diagram. So let assume that the volume V1 here having temperature T and expansion of force which is exerted at the pistons from volume V2. The gas is equal to the area of piston multiplied by the pressure of the gas. Again pushes the piston, which is म्हणजे piston ला खालून पण pressure external आहे आणि वरून पण external applied pressure आहे. So pressure is equal to magnitude and opposite sign of external pressure must be minus of P external pressure. So we can discuss the equation. F is equal to minus of P external into A. This is equation 1. If the piston moves out of the distance T and amount of work is equal to the force multiplied by distance. So that is W is equal to F into D. We can discuss here W is equal to F into D in the last equation. Equation number 2. So substituting value of F in equation 2. So equation 1 must be W is equal to minus of P external pressure into A into D. Equation 3. The product of area of piston and distance moves from volume delta V in the system. Delta V is equal to A into D, that is area into distance. Equation 4. So we can combine equation 2 and 3. We get W is equal to minus of P external delta V, equation 5. But we know that delta V is equal to the difference between initial and final volume. So W is equal to minus of P external V2 minus V1. So that is, we know that the gas expand work done by the system on the surrounding, that is V2 is greater than V1. So W is negative, तेव्हा वर्क हे निगेटिव्ह असणार आहे. The gas compressed, जेव्हा गॅस compressed होईल, work is done on the system when V1 is less than V2, the W is positive. So this is the important equation for work when applied to external applied force when change in volume is takes place. So here these are the points discussed in today's lecture. Remaining points discussed in the next lecture. Thank you.